In this video, we will look at the end behavior of monomial functions. So let's start by looking at the function f of x equals x squared. Now over here in this applet, I have this function graphed. So the black graph here is the graph of f of x equals x squared, and I can vary the value of x. And as I vary the value of x, the corresponding value of y is shown over here on the y-axis. So we can let x and y vary together. Now, if we let x increase without bound, and we imagine taking x further and further to the right, notice that the value of y is increasing and increasing. So as x increases without bound, f of x, or y, is also going to increase without bound. So we could write that using our notation as x increases without bound, f of x also increases without bound. On the other hand, if we let x decrease without bound, so we let x decrease further and further, we keep going to the left and to the left, again the value of y is increasing without bound. So as x decreases without bound, y again increases without bound. And that's because any number squared gives us a positive number, so a very negative number squared gives us a very large positive number. So we can represent this information with as x decreases without bound, f of x, again, is going to increase without bound. If we wanted to, we can multiply x squared by some number. So if we multiplied by some number a that's greater than 0, then that's not going to have any effect on these two statements that we just wrote here. If we multiply by a positive number, then the output might grow a little faster or slower, but we're not going to change signs. The output is still always going to be positive. So we can look at an example of this. Let's suppose f of x equals 2 times x squared. When we look at this graph of 2x squared, it looks similar to what we just looked at before, but now as x increases, y increases twice as fast, and we still have this behavior of as x increases or decreases without bound, f of x is going to increase without bound. However, if we have a negative exponent, so if we look at f of x equals negative 2 times x squared, things are going to change a little bit. So let's go ahead and look at that. Now, once we look at this graph, it looks like a flipped version of our original one. And this is because for any value of x, x squared is going to be positive, and then we multiply by negative 2, and that's going to give us a negative number. So now for any value of x, negative 2x squared is going to be negative, and as we let x increase without bound, f of x is going to decrease without bound. And as I let x decrease without bound, again, f of x is going to decrease without bound. So we could represent those two things with the following statements. As x increases without bound, f of x decreases without bound. And as x decreases without bound, f of x, again, will decrease without bound. Let's look at one more example. So let's look at f of x equals x cubed. We can look at the graph of this thing. And the graph looks something like this. When x is greater than 0, f of x is greater than 0. When x is less than 0, f of x is less than 0. So we switch sign at x equals 0. And as x increases without bound, f of x is going to increase without bound. And as x decreases without bound, f of x is going to decrease without bound. So we could write that by writing as x increases without bound, f of x is going to increase without bound. And as x decreases without bound, f of x is going to decrease without bound. So what happens if we multiply by a negative number? So what if we look at negative 0.5 times x cubed? You should notice that multiplying by a negative number should flip our sign, and this 0.5 means our output should be half as large as before. So let's go ahead and enter that in and see what the graph looks like. So now for values of x greater than 0, f of x is less than 0, and when x is less than 0, f of x is greater than 0. So we kind of just switched signs there. So then as x increases without bound, f of x is going to decrease without bound. And as x decreases without bound, f of x will increase without bound. So in this case, we have essentially the opposite thing as what we had before. So we would say as x increases without bound, now f of x is decreasing without bound. And as x decreases without bound, f of x is now increasing without bound.